Picture this. You're hosting a weekend barbecue. The sun is shining, you've got the grill firing, and, you have a dozen of your closest friends out on the back deck.
Oh, yeah, the perfect summer setup.
Right. Or maybe you're just relaxing on a third-floor apartment balcony with a good book and a cup of coffee, and you feel completely secure, right? I mean, this space just feels like a natural extension of your home.
Yeah, totally does. You don't even think about it.
Exactly. But tucked right behind the siding, hidden completely out of sight, there might be this silent, dramatic, and honestly incredibly dangerous structural risk waiting to just give way. So we are dedicating today's deep dive to unpacking a stack of engineering notes and structural investigations about a highly specific threat right outside our own doors, and that is deck collapses.
Yeah, and it's a really sobering reality to confront.
Yeah.
Because, when elevated residential structures fail, they rarely offer a polite warning.
Right, they don't just creak and groan for a month.
No, not at all. They don't just sag gradually over a few weeks. The failure is sudden, it is catastrophic, and to the people standing on them, the collapse feels like just this random act of the universe.
Like a lightning strike or something.
Exactly.
Yeah.
But structural investigations paint a very different picture. These disasters almost always follow a specific, highly preventable pattern.
And that is exactly why we're digging into this today. Whether you own a home, manage a rental property, or, sit on a strata council, this information is vital because these collapses are not unpredictable mysteries. Okay, let's unpack this. Looking at the source material, the most staggering statistic jumps right off the page. 90% of deck collapses are caused by the failure of one single component.
Yeah, 90%. And what's fascinating here is just the sheer consistency of the forensic data.
Right.
When structural engineers sift through the wreckage of a collapsed deck, they aren't looking at some chaotic web of 100 different potential failures. The math points almost exclusively to one primary connection point that deteriorates over time, completely unnoticed until it hits a catastrophic breaking point.
And that component is called the ledger board, right?
Yes, exactly. The ledger board.
Okay, the ledger board, to make sure we're visualizing the architecture correctly here, is the ledger board basically like the spine of a book, like holding the pages of the deck firmly to the cover of the house?
I like that. Yeah, the spine analogy works beautifully for the static connection. But we have to remember, a deck is a dynamic structure.
Right, people are moving around on it.
Exactly. The ledger board is the primary horizontal piece of lumber, usually a massive piece of wood, that physically bolts the deck's framing directly to the building's structural envelope. So if the house is the cover and the deck joists are the pages, the ledger is indeed the binding, keeping them united. But the sheer volume of work that one piece of wood is doing is just immense. I mean, it is supporting half of the deck's entire vertical load.
Right, because the vertical posts out in the yard are acting as the support for the outer half.
Spot on. That is the vertical equation, yes. But gravity pushing down is only half the battle here. The ledger board is also responsible for anchoring the deck to the main structure, absorbing the dynamic, shifting weight of occupants walking around, and preventing something engineers call outward rotation.
Outward rotation. Okay, let's break that down. If I'm standing on the far edge of a deck, my weight is pushing straight down toward the ground. So how does that translate to an outward rotational force back at the house?
Well, think of the physics of a lever. You have this horizontal platform extending out into space, right? The posts in the yard act as a fulcrum.
Okay, I'm picturing it like a seesaw almost.
Basically, yeah. When downward force is applied to the deck surface, especially out near that outer edge, the joists act like giant lever arms. They transfer that downward energy into a rotational force that wants to pivot on the fulcrum and rip the inner edge away from the wall.
Wow, okay.
And the ledger board and the fasteners holding it to the house are literally the only things fighting that outward pull. If that single connection weakens, the entire deck loses its primary support. It completely detaches from the wall, pivots, and just drops.
Which begs the question, what physical force is actually capable of snapping a massive piece of solid lumber or ripping it right off a house? I mean, a 90% failure rate for one component means something is going fundamentally wrong with how these structures are assembled or maintained over time.
Oh, absolutely.
And the structural notes identify three main killers of a ledger board, which are improper fasteners, lack of flashing, and water intrusion leading to rot.
Right. And those three elements rarely act alone, They usually compound each other to create the ultimate worst-case scenario. And the vulnerability, it almost always begins with the fasteners.
Well, I actually have to challenge the premise of what I'm reading in the notes here regarding those fasteners, because the sources state that older decks were frequently built using simple, standard framing nails or undersized lag screws with completely incorrect spacing.
Yeah, that's very true.
But wait, how could anyone think standard nails could hold up a structure designed to hold a dozen people and heavy furniture? I understand a smooth nail pulls out easily, but if it's so obviously dangerous, why on earth did the building industry widely accept the use of standard nails for decades? Was there just a fundamental misunderstanding of how decks work?
That's a great question. It was really a combination of outdated building codes and a huge shift in how we actually use residential spaces.
What do you mean by a shift?
Well, decades ago, decks were often viewed by builders as secondary, almost temporary outdoor structures. They were essentially just small, elevated patios.
Oh, right. Not the massive entertaining spaces we have now.
Exactly. Formal load calculations and structural engineering oversight were rarely required by local municipalities for a simple backyard deck back then. Builders would literally just use whatever framing nails they had loaded in their nail guns.
Wow.
But as homes evolved, decks grew into these massive outdoor living rooms expected to hold heavy patio furniture, grills, and dozens of guests.
But structurally, a nail is designed to resist shear force, right? Like, its job is to hold two pieces of wood together so they don't slide vertically past each other. It's not designed to resist withdrawal force.
You hit the nail on the head, mechanically speaking.
Pun intended?
Yeah. A smooth shank nail offers tremendous resistance to gravity pushing down. That's shear force. But it offers almost zero resistance to horizontal pullout or withdrawal force.
Which is that outward rotation we were talking about.
Exactly.
Yeah.
When that lever effect starts pulling the deck away from the house, a smooth nail simply slides right out of the wood. Even when builders used undersized lag screws, those fasteners simply couldn't handle the long-term dynamic loads of wind, snow, and foot traffic vibrating the structure over decades. The threads just slowly work loose.
Here's where it gets really interesting, because the research points out that even if a builder used the most robust, heavy-duty structural bolts available, the deck is still doomed if the wood around those bolts is compromised. And the silent threat that destroys the ledger board is just rainwater.
Yep. Water is the ultimate catalyst for structural failure here, specifically when there is a lack of proper flashing.
Let's define flashing mechanically, because the sources cite the lack of it, or improper installation, as one of the most fatal construction mistakes out there.
Sure. Flashing is a critical barrier, usually made of galvanized metal or heavy-duty membrane. It's installed over the top of the ledger board and tucked safely up under the exterior siding of the house.
So it's basically a shield.
Exactly, a deflection shield. Its entire purpose is to break the capillary action of water, forcing rain to flow over and away from the gap between the deck and the wall, rather than wicking down into the connection point.
So if that flashing is missing or cracked, rainwater doesn't just run down the wall, it seeps directly into the microscopic gap between the ledger board and the side of the house.
And once water enters that dark, tight space, it's trapped. There is no airflow to dry it out. Moisture just sits against the raw wood fibers week after week, months after month.
Sounds like a recipe for disaster.
It creates the perfect biological environment for rot. Fungi begin to literally digest the cellulose in the wood. And this is a slow, invisible process happening right behind your vinyl siding or stucco.
You'd never even see it.
Nope. And as the wood decays, its structural density plummets. Those fasteners, whether they're smooth nails or proper structural bolts, suddenly have nothing solid to anchor into. The wood around them turns into something resembling wet cardboard.
Wow. So the structural integrity of the wood degrades completely silently over a decade, but the actual collapse is instantaneous. Which brings us to the tipping point. The real-world scenarios where this hidden, invisible damage finally makes itself known. The sources describe a phenomenon known as the residential party collapse.
Yeah, and it's a terrifyingly common scenario. You invite friends over for a summer evening. The deck has been standing securely for, say, 15 years. To the naked eye, it looks totally sturdy. But hidden behind the siding, the ledger board has 70% of its structural mass rotted away.
Right, so for a family of 3 enjoying a quiet Tuesday dinner, that remaining 30% of solid wood might have been just enough to resist the outward pull. But now you have 20 people over, and someone points to a deer in the backyard, or a group gathers tightly on one side of the deck for a photograph.
And that innocent movement creates a sudden, massive spike in concentrated dynamic load. You're abruptly shifting thousands of pounds of downward and outward force to one specific area of that weakened ledge or connection.
Yeah.
The fasteners, already sitting in decayed wood, finally yield. The ledger board shears entirely off the side of the house. The collapse is triggered by the party guests, sure, but the absolute root cause was the silent water decay over the preceding 15 years.
If we connect this to the bigger picture, this isn't just an issue for backyard barbecues on wooden decks. The engineering sources specifically highlight multi-unit buildings and aging strata balconies as major high-stakes risk zones for these sudden failures.
Yeah, the physics remain exactly the same, but the materials and the visibility of the problem differ significantly. Think about a condo complex with stacked balconies.
Okay, I'm picturing it.
You have water intrusion that manages to get behind waterproof membranes or stucco exteriors. You get the exact same long-term rot in the structural framing tying those balconies into the building envelope. But in multi-unit buildings, the structural connections are usually sealed completely out of sight.
Right. A homeowner can crawl under their wooden deck with a flashlight to look at the wood. But a strata council can't easily inspect a concrete and wood balcony without tearing open ceilings and ripping up waterproof membranes.
Which means invasive structural inspections are frequently deferred until it is far too late. Now, while the ledger board is the primary culprit driving 90% of these failures, the engineering notes do identify a secondary list of causes that act as catalysts for the collapse.
Yeah, the sources mention rotting support posts, corroded metal joist hangers, undersized beams, overloading the deck with heavy items like hot tubs, improper footings, and loose guardrails. But how do these secondary issues actually trigger a ledger board failure? Like, if a post out in the yard is rotting, how does that break the connection at the house?
It comes down to torque and leverage.
Okay.
If a support post out in the yard rots and sinks even an inch into the soil, that entire corner of the deck drops. When that corner drops, it physically twists the entire framing structure.
Oh, I see.
That twisting motion applies massive, uneven torque directly to the ledger board attached to the house. It's essentially prying the board away from the wall. Similarly, if you have an undersized beam that flexes every time someone walks on it, that constant bouncing sends shock waves of vibrational stress directly into the ledger board fasteners, slowly working them loose over time.
It's like a giant game of Jenga. The water damage at the ledger board pulls out the critical bottom blocks, leaving the core completely hollowed out and destabilized. And then a rotting support post shifting, or a group of party guests moving to one side, acts like someone forcefully bumping the table. The remaining friction simply cannot hold, and the whole thing comes crashing down.
That's a perfect analogy. All the engineered structural tolerance has been eaten away. It really only takes one minor dynamic shift to initiate a catastrophic cascading failure.
Well, knowing how sudden and devastating these failures are, if you're listening to this, you might be looking out your window right now feeling a bit uneasy about your own outdoor space.
I wouldn't blame you.
Right, so we need to pivot to the prevention strategy, how to actually spot the red flags and take control of the situation.
This raises an important question. Since the most dangerous damage is often hidden behind siding, how can a homeowner or property manager actually spot the warning signs before a collapse? The sources outline a very clear set of physical indicators that show a structure is nearing failure.
And the first, and honestly most urgent red flag, is the deck literally pulling away from the house. Even a minor visible gap between the deck structure and the exterior wall is a massive emergency, right? Because if there's a gap, the withdrawal force has already won. The fasteners have already yielded.
Exactly. The outward rotation has actively begun. If you see daylight between your deck and your house, the structure is an active failure. Other critical red flags include soft or spongy areas on the deck boards right next to the wall.
What does that mean?
That indicates that water hasn't only rotted the ledger board, but has begun wicking upward into the visible decking itself. You also want to look for rusted, bleeding, or visibly loose bolts.
The sources also mention looking for water stains on the siding directly beneath the deck. Mechanically, that would tell you the flash and shield has failed, and water is actively draining straight through the wall cavity, right?
Yes, absolutely. Visible water stains or joists that look cracked and sagging near the house are immediate indicators of structural compromise. If you observe any of these signs, the recommendation from structural engineers is unambiguous. You must seek an immediate professional inspection. Keep everybody off the structure.
But I have to ask on behalf of everyone listening who might not see obvious exterior damage, if the decay is almost always hidden underneath the flashing or behind the stucco, how can you definitively know your deck is safe? I mean, we can't just guess that the wood inside the wall is dry.
No, you definitely do not guess. You implement the step-by-step prevention strategy laid out by the experts. And the single most effective defense is scheduling a professional deck inspection every 1 to 2 years.
Okay, that makes sense.
And for older decks, built before modern codes, that needs to be an annual, non-negotiable inspection.
Because a professional inspector knows how to probe that specific ledger connection, they have tools to test the moisture levels inside the wood and inspect the integrity of the flashing, even if the exterior looks perfectly fine to a casual observer.
Exactly. A proper safety inspection checklist methodically works through the core vulnerabilities. They'll verify the ledger board attachment, assess the condition and angle of the flashing, check beam and joist integrity, ensure post stability, examine the concrete footings, and test guardrail strength.
That is comprehensive.
It is. They also evaluate the drainage around the yard to ensure water isn't pooling around the structural posts and softening the soil.
And the action plan detailed in the sources is straightforward. If an inspection reveals that nails are currently holding your ledger board to the house, those need to be retrofitted immediately with heavy-duty structural bolts and washers. You must check that flashing for corrosion or gaps and seal them. Any signs of rot must be cut out and repaired the moment they are discovered.
And it is incredibly important to note from the data that modern, newly constructed decks rarely experience these sudden collapses. When a structure is built to modern building codes, utilizing proper structural lag bolts, correctly layered flashing, and rigorous load calculations, they are exceptionally safe.
So it's mainly an issue with older builds.
Yes. The critical risk lies almost entirely with older decks. Structures built before strict waterproofing standards, fastened with nails, and left unchecked for a decade carry a disproportionately high risk.
So what does this all mean? Let's bring all of these engineering notes and structural investigations together into a clear takeaway for you listening. If you remember anything from our deep dive today, it should be this. 90% of all deck collapses come down to the catastrophic failure of one single part, the ledger board. This failure is not a random act of nature. It's almost entirely driven by stealthy, long-term moisture damage and the historical use of improper fasteners, like smooth nails that just cannot resist rotational force. But the incredibly good news here is that regular professional inspections and ensuring your flashing is actively keeping water out of that connection point will dramatically reduce your risk.
Absolutely. Knowledge is truly only valuable when you apply it to the physical world around you. We unpack these engineering concepts so that you can take proactive action before you host your next big summer gathering or, before you load up the apartment balcony with heavy planters. Take a serious, critical look at your deck's ledger board.
Good advice.
If you live in a multi-unit strata or rent your home, contact your property manager and request the date and results of the last structural balcony inspection. Do not assume a structure is safe simply because it was standing yesterday.
It's all about taking the power back through awareness and preventative maintenance. But before we wrap up today's deep dive, I want to leave you with one final thought to mull over based on the physics we've explored. Since 90% of all deck collapses are directly caused by the connection point to the house, that highly vulnerable ledger board constantly fighting outward rotational force, it makes you wonder, if a deck was designed to be completely freestanding, essentially built as a self-supporting island entirely unattached to the house with its own set of 4 posts, would that entirely eliminate the biggest, most deadly risk factor for collapse we've talked about today? It's something to think about the next time you step out.